Welcome back, Math 30-2. We're going to continue on with this lesson. Today, we're just going to do our domain and range of these kind of questions. Like we were talking about before, because these questions have more real-world applications, the domain and range of these kind of questions are limited. Sometimes we can have negative values because they just don't make sense. Sometimes we can have more than certain values because it also doesn't make sense in those kind of questions. So let's look at this question here. Joe had a summer job that pays $12 an hour, and he worked between 15 and 35 hours every week. His salary can be modeled by this equation. S is equal to 12 times H. S is his weekly salary, assuming in dollars, yeah. Which makes sense, 12 times H. If H is the number of hours, that's what it says. If I work 1 hour, I get 12. If I work 2 hours, I get 24, yeah. Describe the independent variable for this problem. So remember, the independent variable is the input. So the independent variable represents the x. So in this case, it is the number of hours. Now, what's dependent on that is our amount we get paid. So that's why that's called the dependent variable. The pay is your s. Okay. Number of hours. Let's just describe it. Just gonna say number of hours there. Describe the range, domain and range using appropriate notation. So my domain, okay, so my domain is my independent, it's my x variable. So in this case, it's my h. So I gotta put an h there this time. Now, it doesn't make sense to get paid negative amounts or go back in time. So I'm gonna have to start off with 0. And you can work anywhere between, oh, he actually doesn't get paid 0 because the minimum amount he ever gets paid on any given time is 15. The maximum he gets paid is, or time-wise, is 35 hours. So it has to be somewhere between those two numbers. Now, yeah, he probably gets paid for a quarter of an hour and stuff, so I'm just going to say HER. Okay, my range is a salary. Now my salary, now when you think about it, since the minimum amount is 15, his minimum amount of money that he can actually get is $420. That went 12 times, oops, that's the max. 12 times the 15, I mean, 180. So the minimum amount of money that he makes is $180. And the maximum, if I use the 35, gives me $420. SER. Now, probably not SER. Kind of doesn't make sense to get paid a repeating amount of money, but what to say because it looks kind of continuous. What does each value in the order pair mean in the context of this question? So if I say 20 and 240, what this means, he worked 20 hours, because that's the first variable, and his salary, yeah, is $240. Does that make sense? 20 times 12, yeah, 240. Okay, so let's look at this next one here. Hector is raising money by wrapping presents in a mall. The function S is equal to 3p describes the amount of money he earns by wrapping presents. And they only have enough wrapping paper to wrap 1,000 presents. So that kind of gives you a maximum here. So my dependent variable is the S in this case. Remember, the dependent is the output. In this case, my Y variable, so this one here is the S. That's my Y variable. This is my X variable. So what does it stand for? The function describes the money he earns. So S, the money earned. Okay. Now this is where it's going to get a little tricky. Our domain, which is our P values, can go from anywhere from 0 to 1,000, because they said you can only go up to 1,000 presents. But the thing is, P, it can't be a real number. It doesn't make sense to wrap half a present. So we have to think of what kind of number that does not have a decimal to it. And that's also a positive number, including 0. So this is a whole number. So that W, remember, stands for whole number, which is 0, 1, 2, 3, all the way up to 1,000 in this case. You can go higher than that too. All right. Now we're using that just because we can't have half a present, right? My range in this one is going to be $0 if he doesn't wrap any presents, he doesn't make any money, up to 3 times 1,000, up to $3,000. Okay. Now this one gets a little bit trickier too. You are going up by 3s each time, so yeah, I'm going to say whole numbers, but it'll just kind of work itself out that S ends up being whole numbers. So you can put in whatever you want there, because my inputs are whole numbers, my outputs are probably going to be whole numbers as well. So, okay. Let's try these next ones out here. So we're going to use this information to solve the next few questions here. The surface area of a cube is found by going 6s squared, where A is the surface area, and S is the side length of one of the sides of a cube. So I'm going to just draw a cube because I want to. So there's my cube. All the sides are the same. Okay. What is the independent variable in this case? Remember, the independent is the x variable. In this case, it is the side length. All right. Describe the domain and range. So my domain, which is my x variables, my s variables in this case, well, it makes sense that I can't go any smaller than 0. It doesn't make sense my side lengths to be 0. So I'm not going to put an equal sign on this one. I'm just going to say it has to be greater than 0. And then my maximum says your geometry wants you to draw cubes that has a length of at least 5. No, so maybe 0 is not the smallest number then. So it says at least 5. So I'm going to go from 5. And then what am I going to go up to? I don't know. There's probably an upper limit at how big I can draw my cube. Side lengths of at least 5. But they're not telling me too much about that, so I'm just going to put in here that my s's have to be greater than 5. S-E-R. Yeah, okay. And then my range is going to be my outputs. So that's my areas, my surface areas. And this has to be greater than, I'm just going to put that in my numbers. So I got 6 times 5 squared. It's 150. One order pair that represents a reasonable input and output for this function, and describe in context of the problem, or at least 5, sorry, I should put an equal sign on that one. And then describe in context of the problem what each number in the order pair means. So one ordered pair I can put in here is 5, 150. Kind of what we had before, where 5 is, oh, that's not is the side length. And 150 in this case, is it inches? Yeah, inches cubed. Oh, squared, sorry, because the surface area is the surface area. Cool. There we go. Balls thrown in the air, and then we have this nice little quadratic here. Got t squared, you got t's. What's the dependent variable in this case? So your dependent variable, you notice that they named the function h. Probably stands for height. This is the height of the ball, yeah. So my dependent variable for this case is going to be the height. And I'll just call that h. This. So my domain is going to be time, that's my input. And this bone thrown in the air with an initial height or velocity, sorry, of 72 feet per second. That 72 is in the equation, but it doesn't help me too much. Yeah, okay. So time, let's say time starts at 0. Now the thing is, I don't know where the time is going to stop. Not just going to be time forever. Eventually the ball is going to come and hit the ground. So what I'm going to have to do is graph this. So I'm going to go back to my graphs here. Let's get rid of this and just type this in. Now when you graph these, you're going to have to replace all the t's with x's to make this work nicely. I think it says 16x squared there. That's what it says. Yeah. Okay. Oh, doesn't look very good. So we're going to have to kind of zoom in here a little bit. Just change the zoom. If you're using Desmos, if you hold down the shift button, you can see that it changes. And if I move my mouse around, I can change the scale of either axis. I can change both if I'm just in the middle of one of the quadrants. But I can do that as well. Okay, so I'm going to look at this graph here, and it says here, there's a few things I want to point out here. So I'm going to highlight all those different points. Those are pretty important. So my time, because it's going to go up and then come back down, my time only actually goes to 4.5 in this situation. Got all this negative distance down here, which I don't care too much for. Graph stops at this point right here. So the ball is coming and it hits the ground right there. Now my range is the up and down part. So that's going to be my height. My height starts at 0. And it goes to that max value I have listed there, 81. So I'm using my variables, my h and my t variables. Cool. And there we go. So the next lesson, we're going to talk about regression. So we have to use our graphing calculators quite a bit. I'm going to pull up my emulator so I can emulate this and show you how to do this on a graphing calculator. And you're going to see how to create lines of best fit just given some random data in the next video, which I think ends up being next week. So I'll see you then. Bye.